Our next session is going to look at the future of work from a much more technical perspective. So we have with us Professor Oussama Khatib of the Stanford Department of Computer Science. He's also the director of the Stanford Robotics Lab. He's going to give us a peek at what's happening on the frontiers of human-robot collaboration.
It's a really great pleasure to be with you, and I'm going to continue with the keyword word that just we heard from the governor and Fefe, collaboration. Human-robot collaboration is going to be a key in the new robots that are coming. Today we see robots in hospitals, warehouses, logistics, service centers. We are seeing robots in social context. Social robotics is developing and growing. In fact, robotics is touching healthcare, it's touching assisted living, assisted work, sustainable nutrition, green planet, the challenging of remote environment where we eventually are going to be able to reach. The impact of robotics in the economy, production, culture, and society is huge. Now, there are challenges. And one of the main challenge I would like to bring in the discussion today is these physical tasks. That is when we are going to perform operations and when we are going to have to program in real-time robots in the new environment. It's not anymore the environment of manufacturing where we can pre-program the trajectories and have this robot performing precisely repeated tasks. So this transition that we are undertaking in robotics today is quite challenging. Offline trajectories cannot be there, and now we need a different kind of programming. We need almost human-like skills, abstractions of the capabilities of the human to be somehow encoded for robots. And then we can think about how to plan with human-like skills. Well, there is also the question of the robots themselves, because when we are relying on offline trajectories, we are relying on robots that are precise and accurate. Now we need a different kind of robot that can deploy the capabilities of human. And these are a different type of safe, compliant robots that we need to have. Let me show you this example. There is no trajectory. The robot is touching, feeling, and moving in the right direction because of the contact force. This is the way humans interact, by feeling and tactile feedback. Well, this idea of how we can observe human and bring those capabilities to be encoded to robots is actually already underway. We are building primitives and capabilities. You can see here how we can let the robot interact with a dynamic environment, changing environment, without having to reprogram anything. The robot is autonomously feeling the contact and autonomously performing the task. So capturing human strategies is quite challenging. However, it is the only way where we can build those autonomous capabilities for the robots. So this is going to be done by demonstration by human, segmentation of what the human is doing, understanding what was going on, and then encoding that for the robot, which is different, and then being able to execute those tasks. So here is an example where we are teaching the robot how to put a cap on a bottle, but it is not recording trajectories. We are extracting the strategy so that we can generalize to different shape, geometries, and positions. Another example of tactile skills. We cannot see this glass with cameras. We have to feel it with touch. And the robot is able now to determine the normals and grasp it, and then not grasp it too much to break it, but grasp it enough to prevent it from falling. Another important thing in robotics, the new robotics, is the fact that we have now no more fixtures. We have no more jigs. We need two hands. And this is going to require studying how we can build those two-hand manipulation skills. If we are going to interact with humans, we need to understand human models. And in fact, robotics is bringing new tools to understanding human models. We are modeling musculoskeletal systems like we do with humanoid robots. In fact, the main and major challenge is safety. Physical interaction requires safety guaranteed both in the hardware and the software, in the interaction, in the way the robot interacts with human. So the collaboration takes place in different ways. Direct contact, here the robot is guided by the human. In fact, Ashimo came to Stanford and spent 10 years with us and learned how to become touch sensitive. The other modality is the one that involves an interface. This is the haptic interface. And this is going to be of a huge impact. We'll have a huge impact in the remote work, in that we are going to be able to distance human from the danger, but at the same time reconnect human skills, intuition back to that workspace. So here is an example of a haptic interaction where the human is guiding the motion, but the robot has the autonomy to do the coordination. This is illustrated here in this example of high tension cable servicing. This is a dangerous task. Can't we substitute for the worker with a robot? But still, the worker has to guide the robot. And here is the example in the lab of this task where we are haptically interacting with the robot. And you can see the robot is disconnecting a cable. And this is going to be done remotely from a safe place. But at the same time, the task is done by the robot in a complete and precise way. Well, let's talk about the ICUs. Wouldn't it be amazing if we can have robots that can substitute for the medical worker in the ICU? It would be wonderful. However, this is not going to happen in complete autonomy. We still need the physician, and the physician can be connected to these robots' hands, and the physician is going to be able to interact. And also, the AI is going to provide all the data, the connection, the expert that can assist in that intervention. Well, this is one of many examples where haptic remote work can allow us to bring this collaboration to fruitful interactions. Here is the robot going from one ICU to the next. And in all of these applications, we are talking about a connection between sensors perception with action. This is going to bring a collaboration both between different robots with the human, but this collaboration is going to take place at multi-layers. It's not one loop. There are different frequencies and requirements. There is autonomy that is built, but it's a functional autonomy. There is an interface with the human, but that is an intuitive interface. And then we can perform this task between the robot and the environment. I'm going to show you an example, exciting example about what we have done in the Mediterranean some years ago with Ocean One. Ocean One was taken to the Mediterranean to dive on a vessel called La Lune. It's a vessel of King Louis XIV. And again, in this example, haptics was key. The haptic devices I'm holding here allowed us to reach to the bottom of the sea to recover a treasure. And this was a Catalan vase from 1664. And in this mission, we were able to deploy the robot in the Mediterranean. And since then, we rebuilt a new robot that can take us to 1,000 meters. This new robot last week at Stanford in the pool, and I'm going for the first time to show this publicly. This robot is a robot that is capable of going to 1,000 meters. But when this robot is going to touch any object there, the human is going to be able to feel it through this haptic interface. And this is an amazing capability that brings robotics with its mobility, manipulation, sensing all together to those interactions. Finally, I would like to just illustrate what we can do in many different areas with haptic robot interaction. And here is a little bit of art performed by one of our researchers at Stanford. Thank you very much for your attention.
Thank you. Thank you so much.
Oussama, that was amazing. Thank you. It's like science fiction, except it's real. It's really impressive what you're doing at the laboratory there. A big part of what you're doing is what we talked about this morning, getting humans and robots, humans and machines to cooperate and work more closely together, augment humans. And you're doing amazing things on the robot side. Tell us a little bit about how much do humans need to learn new things? I mean, for instance, if you go to healthcare, how hard has it been to train surgeons to feel comfortable working with robots? Or is it something where you really try and do all the adaptation on the machine side?
Eric, this is a very good point. We do not want expert and specialists in robotics to use these robots. Mm-hmm. The interface, the design of the interface is very, very important. It has to be intuitive. It has to be easy to use. And actually, we have been working with radiology, doing ultrasonic imaging. We have been working with a surgeon from the School of Medicine at Stanford, exploring those ideas of taking robot to the ICU. And in all of these applications, the surgeon, the radiologists were quite amazed about the easiness of interacting with those robots in the haptic setting. And I think one of the hardest things to explain is how haptics work. And it is really important, and I really hope we will have the opportunity to have you back in our labs when times will change, and then try it yourself. Haptics is one of the most intuitive way to interact. Little kids comes from schools to visit our labs and try it, and they come to become very quickly expert painting and performing different tasks. So this point of easiness of interaction is critical, and that is what we are working on.
Let me ask you one more question. I see Rana's here. I'm going to introduce her, but let me just ask her one more question, which is a bit of a segue, which is, you know, for humans and machines to work together. I noticed you put a happy face on some of your robots. And is there sort of an emotional connection that you're seeing between the machines and the people in terms of how they connect with each other, not just the haptic and the other sensors?
Eric, let me tell you, Ocean One was a very complex system. One of the hardest parts in the design of Ocean One was the face. It took me almost a year repeating, redesigning until getting the right face. Interacting with machines requires really that connection. My archaeologist colleagues were saying, it's amazing. This robot looks like a little child in the water. And I was feeling the need that the robot needed some help from me. And that connection to work with, to bring a human and the machine to work together is very, very important.
Thank you. Well, some of that's remarkable stuff. You know, dexterity is clearly important. IQ is important, but EQ may be even more important. And we now have one of the world's, maybe the world's foremost expert in this, my erstwhile colleague at MIT, Rana el Kaliouby, who's the CEO at Affectiva. And she's pioneered the use of AI and other technologies to analyze complex human emotions. Rana, welcome. Thanks for joining us.
Thank you for having me, and it's a real honor to follow you, Professor Khatib. And I think my work builds very nicely on top of your work. And I actually wanted to start with I wasn't planning to do this, but I think it is very relevant. And let me share my screen quick.
Sure.
Can you see?
Yeah, that's cool. That's Angela Merkel there.
Yeah, let me start from the top here. Yeah, I find this picture really fascinating because it does kind of speak to some of the fear that adults have with respect to robots, but we will collaborate and work alongside these robots and AI systems. And I want to juxtapose it with this picture of my son, who's now 11, this was a couple of years ago, who is fascinated by social robots. We have a few of them at home. We collaborate with MIT, the social robotics team there, building social robots that can be learning companions, that can be conduits in a learning situation. The robot cheers you on when you're excited. It helps manage your emotions when you're frustrated. So there's just so many applications in robotics. And I think kind of the thesis of what I do is that to build truly intelligent machines, you have to marry the IQ, the cognitive intelligence with the emotional and social intelligence, or the EQ. As it turns out, 90% of how humans communicate is via nonverbal signals. These are a combination of your facial expressions, your hand and body gestures, and your vocal intonation. And now, of course, using computer vision and machine learning and voice analytics, we are able to capture these signals and train algorithms that can detect these nonverbal signals in real time and build them into a variety of technologies and devices. I really believe that the ultimate human-machine interface is just going to interact with us the way we interact with one another, through perception, through conversation, and hopefully through empathy. When we spun out of MIT a number of years ago, we kind of structured the company to be on this mission to humanize technology and bring artificial emotional intelligence and human perception AI to a variety of industries. One area where we're spending a lot of time is in the automotive space, which Professor Khatib, I kind of think of a car as a robot on wheels, really, right? And so we're spending a lot of time kind of building this vision of an in-cabin sensing AI that can act as the ears and eyes of what's happening in the vehicle, with applicability in our vehicles today, but of course becoming really important with autonomous vehicles and robotaxis of the future, where there will not be a driver in the vehicle. So I just want to show a quick kind of video of what this will look like, and then talk about some of the other use cases of this technology as well. So you can see the technology in real time detecting various states of the driver, everything from yawning, eye closure. So if we're able to detect expressions of drowsiness as it unfolds over time, the car can intervene. We can also do that for passengers in the vehicle as well. And you can imagine how we can start customizing the riding experience. If you're tired, then the lights can dim. We have to kind of incorporate that in various lighting conditions, different head poses.
Sunglasses.
Sunglasses, facial masks, actually. Distraction is one that we spend a lot of time thinking about, obviously in terms of road safety. And these are all, each of these are very challenging computer vision problems, right? Because you have to detect, you know, different head poses, especially the head turning can be quite hard to do.
And is the idea that an autopilot will engage if the human is not paying attention?
Exactly. You know, you can imagine a semi-autonomous vehicle essentially saying, I'm going to take over control because I'll be a safer driver at this moment in time. You're too distracted or too tired. Gaze tracking is, of course, a key component of this to understand the context. We're doing body tracking, activity detection. So here we can see that this person is both driving and there's a phone in their hand. So they're probably distracted by looking at the phone.
Amazing. I have to ask about the privacy implications of this. Who has access? Who can see what I'm doing in my car?
Yeah, this is a big consideration. All of this is happening on the edge. So none of the data leaves the vehicle at any point in time. In fact, it's not even recorded. It's just processed in real time. I do think, though, there are a lot of privacy considerations and car manufacturers. I mean, a lot of cars already have camera sensors in them, but it's kind of interesting as a consumer. You don't necessarily realize that if you don't really understand how these technologies work. My car has a gesture control system in it. And when I was buying the car, I challenged the salesperson. I was like, oh, how does it do gesture control? And the guy didn't know. And I was like, dude, there's a camera up here. There's a depth camera. This is, you should disclose that. So I think we have a ways to go in terms of the kind of privacy considerations of this. So it's not just detecting the emotions of the people, it's detecting objects like a child seat to identify if a person is left behind. Obviously, face identification is important as well. Because you can imagine how if the car knows it's you versus your partner or your, you know, another person who typically uses the car, it can personalize the environment. And then, of course, it can detect things like your different facial expressions of emotion. Everything from joy, it can track multiple people in a vehicle and again, customize and personalize that experience. So I'll stop here. So this is kind of the application in automotive, but again, you can repurpose the same core technology with collaborative robots, whether they are in you know, the frontline workers in a hospital, right? You could imagine that being a combination of human and robots in the surgery or operation room. It could be in airports, in retail, but also at home. We are partnered with a company, another MIT spin-out called Khatib Health, and they have a robot called Maybu. It's a small social robot that gets sent home with terminally ill patients to help these patients, you know, engage the patient and ensure that the patients are adhering to their medication regimen. And if not, escalate that to a human nurse. So for me, it's about a human robotics partnership. It's not about robots replacing humans. I think you mentioned that with the doctors, right? Like these are tools that augment people. There's a lot of applications in health that I'm very excited about. As well as other areas as well.
Well, I know Oussama was also working in the health area. Oussama, do you want to get in there? You want to? Is that a question?
Yeah. Well, I was going to. Wonderful, Rana. This is. I mean, doing the perception and detecting that a driver is getting tired and might cause an accident. Actually, now we can continue and have a driver wearing a sleeve. And now, haptically, you can send signals to alert the driver about the conditions. And all of this is within the car. So augmentation, I mean, not only that, robot working with human, also the human can receive signals about the interaction and about the intention. And all of that is going to be amazing because we are going to be able to use the perception to create actions that bring safety on the road or in the interaction in the factory or in the hospital. Wonderful.
Absolutely. If I could just jump in there. I mean, that slide that you showed, Professor Khatib, about, you know, the arms, this idea of robotic arms in a hospital room, I think a lot of people might find that kind of scary. So you can think about the importance of a technology that was reading the emotions of the patients, yes, so you can make sure that you're interacting with them appropriately, right? Like that's a huge step in understanding whether or not the patient is in pain or is scared or is confused. Yeah. I mean, like if you were to combine these two things, it could be so much more effective.
Absolutely. Christy, thank you for this question. I mean, this is in our discussion. I mean, many discussions around this idea. The robot will be actually going there with the face of the doctor, the physician, and introducing the interaction in ways so gentle. And I talked about the face, but that interaction is going to take a lot of attention to the way you interact with the gestures, the visuals, the feedback, the gentle touch. All of that is part of it. I mean, in one image, it's very difficult to convey everything, but I really believe that robotics, the new robotics is going to involve the human expert and the human user. And in every task, we are going to need that intervention. It's not anymore the robot in manufacturing working alone in an environment where we structured everything that we can achieve it. So in a way, we shouldn't fear robots, because the robots are part of extension tools of the human, augmentation, and all these things that we are talking about.
So one of the things that I've been saying for a decade, which maybe I'm going to have to stop saying, is that machines excel at routine cognitive tasks, but humans have an edge in emotional intelligence and connecting with other people. How true is that still? Or maybe more nuanced, where is that true and where is it not true? What are the relative strengths today of humans and machines in the area of emotional intelligence?
I mean, I definitely think the work we're doing is about kind of, again, augmenting people's human intelligence, emotional intelligence. It's not about replacing it. There are many scenarios where I feel like our EQ gets lowered. So for example, when you are communicating online, and just take this example, you know, if we were at Stanford all together in this conference, I would get a chance and opportunity to see the audience. And using my EQ, I would personalize what I'm saying in real time based on the level of engagement of the audience. But here we are. What's that?
I think they're all cheering right now.
I hope so. But because we're doing this virtually and we can't see the audience, I feel like my EQ is at 0, right? It's so hard to apply your social and emotional intelligence skills in a lot of our digital communication. So I think that's what an area where, if we had emotion AI integrated into Zoom, and it showed with people's consent, of course, and considering privacy, a real-time bar graph or line graph of how the level of people's engagement, are they excited? Are they bored? Are they attentive? You know, the 4 of us here would be able to personalize the experience in real time. So I think these are kind of examples of situations where this kind of technology can augment humans. Autism is another example. This was the very first application I explored at MIT before starting Affectiva. We designed these Google Glass-like devices with cameras that could read the expressions of people you're interacting with, and it gave you real-time coaching and real-time feedback. And we know that the kids improve in terms of their social skills by using
not just kids. I think a lot of our colleagues.
Right.
But there are places.
Stanford, just like MIT. Is that what
I think everywhere. But I think. So one of the things you showed me in some of our past conversations were places where the technology clearly is better than humans in sort of detecting micro expressions, and sometimes people, you know, very briefly will react to something and maybe try to cover up, or maybe just have a moment of joy or sadness. And if you do high-speed photography, you can pick up on that.
Yeah, absolutely. The technology is there in terms of detecting these very subtle and nuanced and also fleeting expressions. For me, though, we have steered away from applying the technology in surveillance and lie detection and security, because I believe strongly in people's right to consent and people's right to privacy. And so that's an area where, you know, even though the technology is there, we stay away from it. Hi, Eric.
Has anybody tried to use it in there's Eric Schmidt. I'll introduce you in a minute, Eric. Well, actually, you need no introduction. I'll just right now mention it. I think everyone knows Eric is the former CEO and executive chairman of Google, and he's now co-founder of Schmidt Ventures. Eric, feel free to join into this conversation, and then you and I are gonna have a fireside chat in a couple of minutes. But this is really interesting, and I think you may want to join in. Rana, just one more thing on that. Has anyone used this to sort of in playing poker or negotiations to pick up on the other person? You know, our friends at Carnegie Mellon have these amazing poker playing systems that are just very analytical, but they don't do maybe the most interesting part, which is understanding when people are bluffing, et cetera.
We have actually been approached by the gaming kind of in a couple of casinos, but we've never actually implemented it in that space. I think that would be really fascinating. It's that on Botox. We often get the question like, okay, will that work with Botox? I'm like, nope, it won't.
Well, thank you so much, Rana, and thank you, Oussama. You guys are doing just breathtaking work, and it's cool to see some of the cutting edge technologies and some of the applications and some of the ability that you're both augmenting humans, human intelligence, human emotional intelligence. Thank you for joining us.